All right, this quick lesson here is on 31, circular motion. So now the thing with circular motion is this, that under normal circumstances, when you think of something traveling at a constant speed, you don't think there's an acceleration. And this is true. The difference here is the object, when it's traveling at a constant speed, it's not a constant velocity. That's because there's a change in direction. I mean, it's pretty obvious. At this point here, the object is traveling down. As it circles around at this point here, the object is traveling up. Obviously, they're not traveling in the same direction, so there's a change in velocity. Acceleration is a change in velocity over time. So if there's a change in velocity, there has to be an acceleration. The question is, what's the direction of that acceleration? If we pan it up here, if we think of just the basic formula, where A is equal to Vf minus Vi over T. If we take our Vf and subtract Vi, there's our Vi, that's a negative Vi. We flip the arrow direction. So we have our Vf, our negative Vi. You'll notice that the change in velocity is directed inwards towards the center. And that's the way that centripetal force works. Centripetal force is a result of a change in velocity. It's always directed inwards. That's blah, blah, blah. The key thing here is, if you think of Newton's first law, right? An object in motion stays in motion, an object at rest stays at rest. The object is going to be changing in motion because it's changing direction. The velocity is changing. That means, according to Newton's first law, that there has to be a force acting on it. So we call that force, again, centripetal force. Centripetal force. Under many cases, that force is like a force of gravity. So think of planets, right? What keeps a planet in orbit? Well, there's a force of gravity pulling it towards another object, making it travel in a circular path. If I have an object like a car driving on a road, it's going to be a force of friction. The friction actually allows it to go into a circular path. I mean, if you think about an icy road, no friction, object cannot turn or travel into a circular path. It just keeps going in a straight line, right? You come up to an intersection or a curve in the road. If you can't generate a centripetal force, if you can't generate that force of friction, you continue doing what you were doing, traveling in a straight line right off the road into the ditch, and hopefully there's no fence. Now, as far as definitions go in this first one here, what are some things that we need to know? Periodic motion. So, unlike other physics where we were traveling in a straight line, it would go on and on forever. With centripetal force and circular motion, it's a circular path, which means it passes a certain point all the time. We call that a period of rotation. Or another way you can think about it is it's a cycle. A period is a cycle. So a period is how many seconds it takes to complete one cycle. It takes 10 seconds to go around, that's a period. If it takes 1 second to go around, that's a period of 1 second. A new term that comes up often is frequency, which is the inverse of period, which is basically, instead of seconds per cycle, cycles per second. So now you're just actually going to time and see how many times something goes around in a second. So that's why it's cycles per second. Another way of thinking of it is you're sitting on a road and you're watching how many vehicles come by in a certain amount of time, right? That's the frequency. So how often does a semi drive by in a certain amount of time? It's frequency, right? How often? Very frequent or not very frequent? Other terms that are worth mentioning is RPMs, revolutions per minute. So some stuff like for an engine, for example, that's not necessarily represented in a period or a frequency, it's RPMs. So slightly different because it's not revolutions per second, it's basically revolutions per minute. So if you take RPMs and divide it by 60 seconds, because that's minutes to seconds, then you'd actually get a frequency for that. Okay? And I think that's about it as far as terms go. And that is lesson number 1. Things that are worth mentioning, if I go back real quick here, for stuff that's traveling in a circular path that is worth mentioning, if I was at point A or at point B, and we did a rotation, okay, both of those we're going to say would cycle like a clock going around, would cycle in the same amount of time. So the question would be, which one has a greater velocity, right? I would say that the one on the outside is, because it's going to have a greater circumference traveled in the same amount of time. That means If you're traveling on the outside, you're going to have a greater velocity. If you're on the inside, you're going to have a lower velocity. In general, if you have a greater velocity, then that means there's a greater change in velocity, so there's greater centripetal force. Further out you are, greater centripetal force. Closer to the center, the less centripetal force. A good example is think of when you're going to a park, and you have that little kid merry-go-round kind of thing that spins round and round and round. You sit there and you kind of spin it and spin it and spin it, and then when you grab a hold and jump on, you're right on the outside and it's pulling you out. And as you work your way to the inside, you'll notice that the force that you feel is less. There's less actual force exerted on your body. So the closer you get to the center, the lower the centripetal force, the further out, the greater the centripetal force. All right, that's it. We'll talk about lesson 32, I guess, next.